Chapter 4. Heat transfer by conduction. Energy transfer by conduction. When one end of the metal is heated, heat energy is slowly transferred from this hot end to the cold end. The energy transfer by means of conduction due to energy exchange between particles by particle collisions. So at the hot end, particles gain more energy, and these particles vibrate more vigorously. They have more kinetic energy. They then collide with the next particle, and energy is transferred from one particle to another. And in this way, energy is transferred from the hot end towards the cold end. Different substances have different conductivity of heat. Those conduct heat efficiently are good conductors of heat, while those other does not conduct heat very well. They are called heat insulators. And the diagrams below shows two experiments that try to compare the heat conductivity of different materials. Let's now take a look of the video.
Put a copper rod, an iron rod, a glass rod, and a wooden rod into a beaker of hot water. Feel the ends of the rocks to find out which rock feels hot first and which last. Use wax to stick drawing pins at one end of the rocks. Hit the other end of the rocks and observe which drawing pin falls first.
So which experiment is a better one to compare the conductivity of different materials? And for me, I prefer the experiment on the right, which use drawing pins to show when the end of the rod becomes hot, then they fall. So the result is clear. By the way, in this experiment, if the rods have the same diameter, then the first one with the drawing pins falling down show that it has the highest heat conductivity. And now in the experiment, when the right end is heated, then you will see the aluminium will have the drawing pins falling down first, and the second one, copper, and the last one, iron in the middle. If you turn to the next page, then you can see a table that shows you the heat conductivity of different materials. To your surprise, copper should conduct heat better than aluminium. So we have to find a way to explain it. And one way to explain that is because the rods, they don't have the same diameter. And maybe the aluminium rod has a larger diameter, and that's why the wax there melt first. And from the table, we can see that metals are usually good conductors of heat, while non-metals are usually heat insulator. By the way, air has the lowest heat conductivity in the table. So even water is not a good conductor of heat. It is a poor conductor. It is an insulator. Let's take a look at the following experiment, which can show you that water is not a good conductor of heat.
Use a piece of wire gauze to keep some ice underwater at the bottom of a boiling tube. Gently heat the top part of the water and find out if the ice melts.
Isn't it interesting? The water at the top is boiling, while the ice at the bottom is still in solid form. It doesn't melt. The ice at the bottom does not melt even when the water above is boiling. because the heat does not conduct to the bottom of the tube very well. Heat does not conduct very well, and that's why the ice does not melt. The experiment shows that water is a poor conductor of heat.